So now we're going to work through a new problem dealing with colligative properties. As we look through this, we see it's dealing with boiling point of a sodium chloride solution. Now I've scratched out a couple things there. Since we're not doing this live in class, you can't exactly let me know if you have questions. You can't raise your hand when you have an answer. So let us just do it this way, all right? You're going to pause me and take time to write down that question, and then you're going to try to work the problem, okay? And then rejoin me. What I'm going to do, if you want to rejoin me, is I'm going to be quietly working the problem for a little while, and then we'll go back and do explanations. But I don't want to distract you if you kind of peek in and look at what I'm working on and what I've written down. I don't want to break your train of thought, okay? So you're pausing, you're writing it down, you're starting your work, and then you are rejoining me as you want. Okay, so you've rejoined me, you've looked at your work and my work, and I've considered through all the pieces that you need to consider in order to do this. What are the common mistakes of students? Well, they put in that 101.32 for this. Remember, this is how much it's elevated by. It's boiling point elevation. The normal boiling point of water is 100 degrees Celsius. So this has gone up by 1.32 degrees. I always include the I. Your textbook doesn't always do that. But I always include it to make you think about that Van't Hoff factor. Besides that, it spells my first name, and that's just too cool, right? So we've got our I. We have to think about what the compound is, and it's sodium chloride. Sodium chloride breaks apart into two particles, so it has a Van't Hoff factor of 2. We're trying to solve for the molality, and that is the little m, okay? And let's consider for just a minute, because we're going to carry this to a next step. What does that little m mean? In gory detail, it means 1.27 moles of what? Sodium chloride per what? 1 kilogram of water. Okay, so that's what the molality has to be of sodium chloride in order to bring that boiling point up by 1 whole degree. Now, the second part of this problem is going to be us considering why we add salt to boiling water when we're cooking spaghetti, okay? Any kind of noodle, they'll say, you know, put some salt into the water, or maybe your mom taught you to do that. And I can remember when I was in, chemistry in high school, they said, oh, the reason you do that is because it elevates the temperature at which water boils. And if it elevates the temperature, it will cook faster. Now that is true. When you cook at 101 degrees, when water boils at 101 degrees, it will cook faster than what it will do at 100 degrees. So that is an absolute true fact, but the reason we add salt to water isn't quite there. So I want to have a part 2 of this question. We'll do another recording where we consider how much salt would you have to add to 2 quarts of water to bring that boiling point up to 101 point, what was it, 32 degrees Celsius.